This is the Module 2 test. Do problem number 14. Number 14 asks, in a calorimetry experiment, a calorimeter is filled with 125 grams of water. The initial temperature of the water is 22.3 degrees Celsius. Down. And the water, 22.3 degrees Celsius. Okay, and this is the mass of the water. Okay, a 50.0 gram chunk of metal is dropped at 123 degrees. .0 Celsius is dropped into the calorimeter and the temperature increases 24.5 degrees Celsius. What is the specific heat of the metal? You can ignore the heat absorbed by the calorimeter. Okay, so for this one we need to know a couple of equations. First we need to know Q equals mc delta T. We also need to know that the negative Q of the metal is going to equal the Q of the calorimeter plus the Q of the water. Now the Q of the calorimeter we're told to ignore. We're just going to ignore it. So the negative Q of the metal we're going to calculate as from the Q of the water. So in order to figure out that, I have to figure out the Q of the water. Q is mc delta T. Okay. Excuse me, this is not the delta T. This is the final temperature. Okay, so delta T is the final temperature minus the initial temperature. That's 24.5 degrees Celsius minus 22.3, that is 1.2 degrees Celsius is the delta T. Okay, sorry for shaking the camera a little bit. I'm just going to pick up my paper here. So the delta T of the water here is 1.2 degrees. Okay. So going back here, Q equals 125 grams times the C of water, which we have to know is 4.184 joules per gram degrees Celsius, times delta T, which is 1.2 degrees Celsius. Okay, so we say 125 times 4.184 times 1.2 equals. So the Q of the water is 627.6. Cancel joules. We have 2 significant digits, 4 significant digits, 3 significant digits. So 2 is what we want. Those are the ones we want. We're going to say Q is 630 joules. Okay? So the Q of the water did I really do that? This is 2.2. I beg your pardon. That's not 1.2. 1.2. It's 2.2. This is wrong here. Let me recalculate that. The Q should be 125 times 4.184 times 2.2. Okay, that's more better. Q is 1,150.6 joules. But again, we still only have 2 significant digits. We only want to have 2 here. So the Q is 1,1200 joules. That's what I'm going to say. So if that's the case, now we can calculate water. The negative Q of the metal is going to be the Q of the water, which is 1,200 joules. That means the Q of the metal is negative 1,200 joules. So let's set that using this formula for MC delta T. Now it's going to have a delta T. The initial temperature of the metal is 123.0 degrees Celsius, and the final temperature is 24.5. So I'm going to say 123 minus 24.5. No, not. I'm going to say, sorry, delta T, I should write this out every single time, is T final minus T initial is 24.5 minus 123.0. So that's 24.5 minus 123. So the delta T is negative 98.5 degrees Celsius. Okay, so I'm going to say the negative Q of the metal is going to be 50.0 grams times some kind of C, which we don't know, times delta T, which is negative 98.5 degrees Celsius. So since I know Q, I'm going to set it up to solve for C. C equals negative 1,200 joules, which is Q, divided by M, which is 50.0 grams, times delta T, which is negative 98.5 degrees Celsius. Okay, my negatives will cancel each other out and I'll end up with a positive number. So now I'm going to say 1,200 divided by, open parentheses, 50 times 98.5, close parentheses. So C, make sure you can still read this, C is 0.24365. Okay, a bunch of numbers we don't need. This has 3, this has 3, so this has 2. 2, I can only use 2 significant digits. So I'm going to say C, you can read this, C is 0.24 joules per gram degrees Celsius. That is the specific heat of the unknown metal if we ignore the Q of the calorimeter. Okay, and that's it for problem number 14.